Hello, science friends. We're back again, this time to talk specifically about earthquakes. An earthquake is a natural process caused by the movement of parts of Earth's surface. Earthquakes start along a fault boundary. A fault is a break in Earth's surface where huge slabs of rock slip past, move away from, or push against each other. The slabs of rock often become locked together along a fault line. If the slabs break free, energy is released and moves through the rocks. This makes the ground shake. So let's kind of go over that process again. So you have this place called a fault. Some people call it a fault line. So that's where there's a break in the Earth's surface. Okay. At that break is where the giant pieces of rock underneath of Earth's surface, they're in this, they call them slabs. Okay, giant pieces. They're moving. They could be moving away from each other. One could slip over top of another, or they could just both push against each other. Okay, and if that happens, that movement is energy movement. And when that happens, it causes the ground above, which is where we are on the surface, to shake. And that's going to be an earthquake. Okay, it depends on how these things underground move, how these slabs of rock move. If they move gently, we might only feel a little bit of shaking. But if they move a little bit more and have more energy, that's going to create a larger earthquake on our surface. Several million earthquakes occur every year. Most of them happen far from people or are too weak for people to notice. Okay, there could be an earthquake happening somewhere around the earth right now, and we might not know it. Okay, you guys know we are in an area where earthquakes do not happen frequently, and if they do, we don't really feel them. In my whole life, I can only remember one, and it was probably about, maybe 10 years ago at this point. But I'm terrible with dates, so you have to excuse me on that. And that was the only instance where I can remember an earthquake that was large enough for us to feel it, but it was not a large earthquake in comparison to some other places around the world. But in our area, we very rarely get any kind of activity like that. Okay, and that's mostly because we're not located near any faults. Okay, so although there are tons happening, and believe me, there are scientists that are monitoring earthquakes all over. The ones on the surface, the ones under the water, they're monitoring these all the time because they definitely have tools that can help monitor this to know when they're happening, and we'll get into that in future lessons as well. Strong earthquakes can be very dangerous. Their violent shaking can raise and lower the land and change the course of rivers. Powerful earthquakes can damage buildings and other structures. Roads buckle, railroad tracks twist, and bridges collapse. Water pipes and electric power lines break. It can take years for people to repair the damage caused by a strong earthquake. Okay? And that is absolutely true in places all over the world. I don't know if any of you are fans of the I Survived books, but there's definitely an I Survived the earthquake, the Great Earthquake of San Francisco, and I can't remember the exact year, but I think it was sometime in the 80s. So if you'd like to see some accounts of that and see kind of what it might have been like to live through that, that'd be a great book for you to check out. But it is true that when these happen, there are lots of damage, and it takes a really, really, really long time to repair this. So let's see the type of damage. Let's go over that again. Okay. So when this shaking occurs, first of all, the land can change. So remember how a little while ago we talked about how the plates, the slabs underneath the earth could be pushing against each other? Well, if you take your hands and hold them right out in front of you flat, and then you push them against each other, your fingers start to push up towards the ceiling. The same thing happens when slabs of rock underneath the Earth's surface happen too. That's how mountains are created. And any of you that are doing ELA with either Mr. Terranova or Mrs. Kratz and Miss Natali, that is something that you will learn about in upcoming modules about the process that helps mountains form. And that's one of the ways that happens. Okay. It can also change the course of rivers because as the land around it changes, the land may move upward, the land can even move lower. That could change the way a river is flowing. Okay. It can also damage buildings and other structures, and we'll get into talking about this picture in just a second, but you can clearly see that there is a severe amount of damage caused by this earthquake, okay? So definitely buildings, not only can they collapse, they can be just damaged. And while they may be damaged enough that they don't collapse right away, they could collapse later, okay? There's definitely lots of other things that happen. Windows are breaking. Things inside the building are damaged that can cause other things to go wrong, okay? The roads could be buckling, okay? We talked about that in the last lesson, how the roads could break apart, and we saw a picture of that, okay? Railroad tracks can twist, because railroad tracks are just set on the earth, so if something happens to the earth, that could cause them to twist. And if there's no train on the tracks at the time, it's not that it's not a big deal, but at least no damage was caused to the train then. But if a train is riding along tracks and an earthquake occurs and they're in that spot, it could mean big damage for the train and the passengers as well. Bridges can collapse, which means any cars that could be on the bridges could collapse with the bridge. Okay? And in a little while, in a few lessons, we are going to talk about how we can do better with that. Okay? So it can take years for people to repair the damage caused by earthquakes because water pipes and electric power lines can break. And a lot of those could be located underground, so which means they'd have to dig up under the ground to repair them before they can rebuild buildings on top. So there's so many things that could go wrong with earthquakes. But now I'm going to tell you one of the most important things that you're going to need to remember for this whole unit. There is no way for us to stop natural hazards. We can't stop an earthquake from happening. There's no science out there. There's no technology out there that can help us stop an earthquake from coming. If an earthquake is going to happen, it's going to happen. However, although we cannot stop natural hazards from happening, we can take steps to reduce their impacts, which means there are things that we can do that will make it less hurtful for the people, for the buildings, for the land around it. So in coming lessons, we'll be talking about the fact that even though we can't stop an earthquake from happening, there are things we can do when we design buildings and bridges and things like that that will help make it less damaging when an earthquake happens. Okay, so let's look at this picture. This is a picture from 2007. This is a 2007 earthquake destroyed this building in Osaka, Japan. Okay. So let's kind of look at this picture and see what we notice. Okay, first of all, I'm guessing that's not how the building was built. I'm guessing this building was probably sitting flat on the ground before this earthquake. Not only has the building tipped over, I'm looking and seeing that windows are broken, which means there's glass everywhere. Pieces of the building have begun to come off, which you can see on all the sides. Okay, there's rubble inside from the things that have been damaged. The floors have been damaged. The walls have been damaged. We can infer, although we can't see it, that any power lines attached to this building were damaged. Any water pipes in this building were damaged. And a particularly difficult thing to control is gas lines. Okay, we kind of talked about that a little bit, where if you have an electric stove or a gas stove, I know our class has talked about that a little bit. Gas is a very fragile thing. It can help you in your home. It can power your stove. It can give you heat in your house. But if those lines break and the gas starts to leak, that's a very, very dangerous thing, because if a fire were to start around it, it would create sort of an explosion type of situation. So that's also very important. Okay, so lots of things inside this building that we can't even see have been damaged as well. So let's talk about the important things we need to remember when we leave this lesson today. Number one, a fault is a break in the Earth's surface where huge slabs of rock either slip past each other, move away from each other, or push against each other. Along a fault line is where earthquakes happen, because the pieces of rock become locked together, and then when they do start to either move toward or away from each other, that energy rises to the surface and causes the surface where we are to shake, creating an earthquake. Earthquakes can affect land features by raising and lowering the land, and also changing the courses of rivers. If strong earthquakes happen, they could damage buildings, damage roads, railroad tracks, bridges, water pipes, power lines. All those things can be damaged if there is an earthquake. Based on the damage that we see here, we can see that the building has collapsed. Other things have broken around it, and we can infer that things inside the building were damaged as well. Okay, hope you had fun learning about earthquakes, and although they are scary, again, we will talk about ways that humans have created to minimize or reduce the impacts of earthquakes on humans in a future lesson. Have a great day, everyone.